Okay, math analysis. I went through this whole thing of notes and I realized it stopped recording at this point. So that's why you have two links for 10-1, one for the first part and one for here. So now I'm going through this again. Maybe I'll be better the second time. This is the Fibonacci sequence, and this is a classic recursive sequence that you see in nature. And a recursive formula, you have to know the previous terms before you can get the next term. And the Fibonacci sequence, you have to know the first two previous terms. So in this case, those are the first terms, and that forgot to have that first one. So first term is 1, second term is 2. You can see they've given you all the way to 13. All you're doing is taking 1 plus 1, and that gives you 2. 2 plus 3, and that gives you 5. 1 plus 2 gives you 3, and then 2 plus 3 gives you 5. 5 plus 8 gives you 13, and 8 plus 13 gives you 21. And that's your next term. All right, here we go again. All right, I'm doing this one more time. So, in this case, this is different than explicit. You don't plug in 1 to get the first, 2 to get the second, 3 to get the third, 4 to get the... Sorry, it just told me that my first recording uploaded. Lots of distractions here. Sorry about that. So anyway, your first term is 3. So you don't need to do any work. No work needs to be done to get the first term. And then to get the second term, you got to plug in a 2 for n. And you notice in that little subscript, 2 minus 1 gives you a sub 1. And what is a sub 1? It's 3. So 2 times 3 plus 5 gives you 11. Then to get your third term, a sub 3, you got to plug in a 3 for n. But how did you get that a sub 2? Well, because that's n minus 1. What was a sub 2? It was 11. Now and that gives you 27. And then your fourth term, it's going to be 2 times a sub 3 plus 5, but a sub 3 is 27. So you get 2 times 27 plus 5, which is 59. So you can list them. Again, if you are confused by any of this, you need more time, more explanation, there will be a Zoom session. Also, if I'm moving too fast, which we all know Ms. Kaiser does, and especially that this is the second time I've gone through this and my recording stopped, just pause. Just pause the recording and catch up. Anyway, find the first 4 terms. Same problem as the previous problem. The only thing I'm going to do here, I'm going to skip this middle step. I'm going to go straight to writing, instead of writing a sub 2, instead of writing 3 times a sub 1 plus 2, I'm just going to write what a sub 2 is, which is 5. So if you notice, I'm just skipping writing this middle part here. I'm going straight to writing to the second part. All right. So see if you can try and find the last 2 terms, the third term and the fourth term. Alrighty, here we go. So again, the 17 was the second term, so 3 times 17 plus 2 gives me the third term. And then 3 times 53 plus 2 gives me the fourth term. And then we list all our terms. Okay. Any questions on that? Wonderful. Well, I don't know if you have questions. You need to let me know. All right, here we go. Factorial. There's a factorial button on your calculator, but you don't necessarily need it if you don't know where it is, but it's under probability on both the scientific and the graphing, and it's an explanation point. And it is, if n is a positive integer, the notation n factorial is the product of all positive integers from n down to 1. So n factorial is n times n minus 1 times n minus 2, so on, all the way down to 1. So we're going to find the first 4 terms for this one. So 220 over 2 factorial. 2 factorial is 2 times 1, and that's just 2. So 20 over 2 is just 10. So a sub 2, and this is back to an explicit formula, not a recursive, where you just plug in 1 to get the first term, 2 to get the second term, and so on. So we've got 3 factorial. 3 factorial is 3 times 2 times 1. And what is that? Yes, it's 6. And we're not going to do a decimal here. We're going to reduce the fraction. Okay? And then a sub 3 is going to be 20 divided by 4 factorial. 4 factorial is 4 times 3 times 2 times 1, which is 24. Reduce the fraction. 5, 6. Again, pause me if I'm going too fast. We need to pause me. We should do that in class too. Pause. Anyway, getting a little crazy in this shelter in place. Anyway, a sub 4. So we know that that's going to be 5 factorial, right? And 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Cross out the zeros, reduce 2 over 12 to 1/6. And we've got it. There's our sequence. Alrighty. Moving on. So we already knew this 5 factorial. We already did it on the previous page. That's just 120. All right, so you can expand factorials by saying 10 factorial is 10 times 9 factorial. 7 factorial is 7 times 6 factorial. So we're going to expand 11 factorial all the way down to 2 factorial because there's a 2 factorial on the bottom and we can cross it out. And then we can use our calculator and multiply. All right, 8 factorial, I'm going to expand to 5 factorial because that's the largest factorial on the bottom. And then I'm going to expand the 3 factorial as well. I can cross out the 5 factorials. And then 3 times 2 on the bottom gets you 6, so I can cross out the 6. We get 56. So n factorial expanded partially is n times n minus 1 factorial. And then you can see the n minus 1 factorial gone. So I can go over some homework problems if you need it in a Zoom session on these problems. All right, moving on. Here we go. Summation notation. Last sort of section in the notes. We're going to do this also for the next couple sections. So that k on the top is the upper bound. The n on the bottom is the index. The 1 is the lower bound. And a sub n is the nth term. So you're going to expand, which is an addition of numbers, and then you're going to tell me what the actual sum is, which is a single number. So when I expand, I'm going to plug in a 0 for n. So what's 0 plus 1? 1. And then I'm going to plug in a 1, then I'm going to plug in a 2, then I'm going to plug in a 3, then I'm going to plug in a 4, then I'm going to plug in a 5, all the way to 11. And if I plug in an 11, my last number is 12. So it's really just 1 to 12. So this is the expanding. So you would need to write this out. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. That's expanded. That's expand. So when you expand, that's what that is. And then evaluate is that. So evaluate is that number. Okay? All right, moving on. This one, a little bit less work. We plug in a 5, a 6, a 7, and an 8. So the index is, instead of an n, it's a k, but it doesn't matter what variable it is. So we've got plugging in a 5, then I'm going to plug in a 6, 7, and 8. So I'm going to go ahead and do that. Okay? Pause me if I'm going too fast. All right, after I've plugged in 5, 6, 7, and 8, my expansion would be the sum of the numbers. So I write it 13 plus 16 plus 19 plus 22. That's my expansion. Then my evaluate is 70 because that is all those numbers added up. Alrighty, let's go to these next two examples. We used I instead of N, which is fine. So this is 1 to 6. So I'm going to plug in a 1 for I, then a 2 for I, a 3 for I, a 4 for I, all the way to a 6. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. 5 squared is 25 times 2 is 50. 6 squared is 36 times 2 is 72. Expansion. Get out my calculator, add it all up. Okay. Next one, plug in a 3, 4, and a 5. So I plugged in a 3, a 4, and a 5. So my expansion is 5 plus 13 plus 29, and my evaluate is 47. All right. Next, we're going to go backwards. Going backwards. So I am squaring 1, 2, 3, 4, all the way to 9. So n starts at 1 and goes to 9, and it's just n squared. That one's pretty simple. The next one, I'm going to 1 to n, and it gives me the nth term, so that one was not much work. Tells me it's 2 to the n minus 1. All right, the next one. All right, I usually like to start with n equaling 1, but you don't have to. And so I'll show you two options. If I started with n being 1, then my first term needs to be n plus 2. There are 4 terms. You can see there's 4 terms. And it's n plus 2 to the third power. You plug in a 1, you get 3 to the third power. You plug in a 2, you get 4 to the third power. You plug in a 3, you get 5 to the third power, and so on. Another option would be start with n equaling 3. Then you go to 6, 3 to 6, 3 cubed all the way to 6 cubed, and then it's just n cubed. Either one of those are acceptable. All right, getting close to done. D, same idea here. I'm going to show you two options. One is we know that it's 3, we know it's squaring a 3. So when we take a look at that, if I start with 1, there is 6 terms there. And so 3 is being raised to the first power, second power, third power, fourth power, and so on. But 3 is being raised to the 0 power first to get 1. And then 3 is being raised to the first power to get 3, but that's your second term. So that's one option. The other option is to start at 0 and go to 5, because there are from 0 to 5 is 6 terms, and you can do that option. All right, last problem. On your first day working in the Piggly Wiggly supermarket, you are asked to stack cans of pumpkin puree for a holiday display. You start by putting 12 cans on the bottom of the display, and each row has one less can than the previous row. If there are 7 rows, express the sum of all the cans in the display using sigma notation. Well, first I'm going to expand it. So I've got 12, and then I've got 1 less, so I've got 11, 10, 9, 8, 7, 6. That is 7 rows, right? That's 7 numbers. So how do I write that in sigma notation? Well, there's 7 numbers. If I start with n equaling 1, and I go to 7, it's 13 minus 1, because 13 minus 1 gives me 12. 13 minus 2 gives me 11, and so on. We are going to learn in the next chapter, we are going to learn a quick formula for that expression, 13 minus n. Okay, well, so what you want to do is print out the blank homework for 10.1, and then you want to do it, and you can check with the key. And you're going to submit everything through Google Classroom. There'll be links telling you I'm going to assign it today and have it due next Monday. Same thing with 10.2a. I'm going to do that video next. Okay. Have a great day, math analysis. Jude, send us another joke. Miss seeing you all. Last I looked, everybody had signed up but 2 people, but I sent them emails, so hopefully everybody's signed up for Google Classroom. All right. Have a great day.